Hello everyone, welcome back to the second part of the collision chapter. In the last class, we studied about collision, we studied about the mechanism behind collision, and we studied about different types of collision. Now, in today's class, we'll study a bit in more detail about what happens during perfectly elastic and perfectly inelastic collision. Okay? Starting with perfectly elastic collision. If a collision is perfectly elastic, then what happens during perfectly elastic collision? All of the energy that was all of the stored elastic potential energy for deformation is given back to the system, right? So because of that, the kinetic energy which was initially present in the system is equals to the final kinetic energy of the system. So the total kinetic energy of the system during elastic collision, during perfectly elastic collision remains conserved, right? Kinetic energy before collision will be equals to kinetic energy after collision. However, the kinetic energy during the collision will not be the same. Reason being, I already told you that some of that kinetic energy is stored in the form of elastic potential energy of for deformation, right? However, after collision, that kinetic energy, that stored elastic potential energy of deformation is given back to the system in the form of kinetic energy, right? Now, so if we sort of solve this formula, this part mathematically, we get this formula, okay? M1 is equals M1 multiplied by U1 whole square minus of V1 whole square is equals to M2 multiplied by V2 whole square minus of U2 whole square. Why is this, why have I written all of this mathematical formula is because it's not for you to remember these formulas, but you can understand, right, that this came from simply like from conservation of kinetic energy. I was able to derive this part, right? You don't have to like remember it for sure. It's just that it's plain simple logic, so you should be able to know where it came from. Now, for elastic collision, for perfectly elastic collision, there is conservation of kinetic energy of the system after and before collision, right? And yesterday's class itself, I already told you that during any type of collision, there has to be what? During any type of collision, the momentum, the linear momentum is always conserved, whatever that type of collision is. So the momentum before collision will be equals to the momentum during collision will be equals to the momentum after collision, right? So if we like sort of conserve like sort of equate this part, initial momentum is equals to final momentum, then we get this equation right over here, right? Okay, and this is our equation 2, and we had our equation 1 here, right? We had our equation 1 here. So if we divide both of these two equations, we get this part. U1 plus V1 is equals to V2 plus U2. And if we sort of arrange this, then we get U1 minus of U2 is equals to V2 minus of V1, where U1 and U2 are the initial velocities of the two bodies that were colliding, and V1 and V2 are the final velocities of the two bodies that were colliding. U1 minus of U2 is called as the relative velocity before collision, okay? This is also called the velocity of approach, the velocity which the body with the fastest speed comes and approaches the other body, and then the collision happen. While V2 minus V1 can be considered as the relative velocity after collision, and it is also called as the velocity of separation, okay? So this is sort of important. This was what was important. So for elastic collision, velocity of approach is equals to velocity of separation, or you could say that the relative velocity before collision is equals to relative velocity after collision, or you could simply say u1 minus u2 is equals to v2 minus v1. Okay. Now, for elastic collision, conservation of linear momentum is valid. In fact, conservation of linear momentum is valid for any type of collision. For elastic collision, there's also conservation of kinetic energy. That is, kinetic energy initial is equals to kinetic energy final. For elastic collision, the velocity of approach is also equals to velocity of separation, right? Now, last thing is that the ratio between the velocity of separation and velocity of approach is denoted by the letter E, and it is called as the coefficient of restitution. Okay, so what is coefficient of restitution? It is basically the ratio between the velocity of separation and the velocity of approach. Okay, since for elastic collision, velocity of separation and velocity of approach are same, therefore this ratio becomes 1. Okay, so for elastic collision, the value of coefficient of restitution becomes 1. Okay, now moving on. When two bodies of equal masses collide with each other elastically, then their velocities will get interchanged after the collision. Okay, so when there are two bodies that have equal masses, okay, and they collide with each other perfectly elastically, okay, then what happens is that the velocities get interchanged after collision. So let's say that this is body A and this is body B. Okay, body A has mass m and body B has mass m2. Body A was moving in this direction with u1 and body B was moving in this direction with u2. So after some time, A and B collide. Now what happens is that after collision, they go their separate way. This is body A and this is body B. Both of them has the mass m. Now after collision, body A will have the velocity u1 and body B will have the velocity u2. Okay. So what happens is that when two bodies of same masses collide, after collision, they gain the velocity in the interchanged way. Okay. Now, Newton's law of collision. With the help of coefficient of restitution, we can find out the type of collision, right? What is coefficient of restitution? Coefficient of restitution is basically the velocity of separation divided by velocity of approach, or you could say that it is the ratio between the velocity of separation divided by and velocity of approach. Okay. Now, one thing that you should know is that, for example, for elastic collision, we just studied that the value of coefficient of restitution is what? 1. So if the value of coefficient of restitution is given as 1 in the question, then you will already know that it is okay. It is perfectly elastic collision. If the value of coefficient of restitution is 0, in that case it is perfectly inelastic collision. Okay, because and we'll study how that happens when we are studying about perfectly inelastic collision. But if the value of coefficient of restitution lies somewhere between 0 and 1, then that will be the case of partially elastic or partially inelastic collision. Okay. Now, so this coefficient of restitution basically helps us in finding whether the collision was elastic or inelastic or partially elastic or inelastic, right? And what is this coefficient of restitution? It is basically the ratio of velocity of separation and velocity of approach. Now, let us talk about what is the case of perfectly inelastic collision. After the collision, both the body will stick together and move. So in perfectly elastic collision, we saw that two bodies were moving separately with some initial velocity and initial kinetic energy. They did collision, right? And then after collision, they moved separately again, right? What happens during perfectly inelastic collision is that we had two bodies with different masses and different velocities, and they had initial kinetic energy, right? Now, what happens is that they collide, okay? And some of their kinetic energy is changed into elastic potential energy for deformation. After collision, absolutely none of that stored elastic potential energy of deformation, EPED, is returned back to the system. None of that is returned. So the kinetic energy is not conserved in this case. And also what happens is that in this case, when I told you, right, during collision, both the bodies move with a common velocity vc, right? in case of perfectly inelastic collision, the body continues to move with that VC. They never separate from each other. They never get separated from each other. Okay, so the momentum remains conserved. Very obviously, I have already told you that whatever the type of collision it is, conservation of linear momentum will always be valid, right? Now, momentum remains conserved throughout the collision, but kinetic energy will not be conserved before and after the collision, as some of the kinetic energy will be lost in the EPED. Okay. So what happens is, initially we had two bodies with mass m1 and m2. They were moving with the speed u1 and u2, and later on, after collision, what happens is that both the bodies start to move together with a common velocity vc. Okay. Now, moving on. Okay, so kinetic energy in this case, initial kinetic energy is not equals to the final kinetic energy. That is, the conservation of kinetic energy is not applied here, right? If initial kinetic energy is greater than final kinetic energy, then that means that there is a loss in kinetic energy, right? If there's a loss in kinetic energy, then we'll have what? We'll have a del kinetic energy as positive. And if there's like a gain in kinetic energy, like if kinetic energy final is greater than kinetic energy initial, then this will come out as negative, right? Now, so you can find the change in kinetic energy by basically kinetic energy initial minus of kinetic energy final, right? Now, momentum is conserved throughout this case. Okay, so P final would be equals to P initial. Obviously, we know that. And the coefficient of restitution in this case comes out to be 0. Why? Because there is no velocity of separation. Think about it. Both the bodies come together and they keep on moving with the same velocity, the common velocity vc. So if they both have the same velocity of separation, same velocity at the end, then that means that the velocity of separation will be 0, right? And if the velocity of separation is 0, then that means the coefficient of restitution, which is basically the ratio between the velocity of separation and velocity of approach, will also be 0, right? So for perfectly inelastic collision, the coefficient of restitution is 0. Whenever a light body collides with another heavy body, then velocity of the heavy body is assumed to be constant after the collision, right? So there is this simple note that whenever a light body, extremely light body, collides with an extremely heavy body, then the velocity of the heavy body is assumed to be constant after the collision. Okay, this was it for the collision chapter. This is all you need to know at IMAT level. I hope you all were able to understand everything for this chapter. Till the next chapter, take care of yourself.